Function 7, the modulus function. The absolute value of x, or modulus of x, denoted by x there in the center with two strokes at the middle, two strokes at the side, is defined as the mod of x is equal to x if x is greater than 0, the mod of x is equal to 0 if x is equal to 0, and the mod of x is equal to minus x if x is less than 0. Now, x being less than 0 means that x is negative. And so a negative times a negative would give you a positive. So from the definition, we can see that the mod function only returns positive values. We can see that the mod functions only return positive values. The graph of the modulus function. The graph of the function, the mod of f of x, can be drawn from the graph of y is equal to f of x by reflecting the section of y is equal to f of x that is below the x-axis to above the y-axis, with the y-axis being the mirror line. And the idea here is that the section below the x-axis, the values of y are negative, but the mod function only returns what? Positive values. So that section below the x-axis, which is the line y is equal to 0, must be reflected to above the y-axis above the x-axis where y is positive. All right, example 7. Example 7 says, sketch the graph of y is equal to x. Hence, sketch the graph of y is equal to the mod of x. Well, first of all, the line y is equal to x passes through all points on the graph where x and y have the same value. So let's see if we can, this point here is the point 1, 1. X and y have the same value. 2, 2, 3, 3, etc. The line y is equal to x passes through all points in the graph where x and y have the same value. It also pass through this point here, which is 3, minus 3, minus 3. So let's draw a sketch. All right, so this is a sketch of the graph y is equal to x. Now, to sketch the graph of y is equal to the mod of x, what we basically have to do is reflect the section of the graph that is below the line, below the x-axis, which is the line y is equal to 0. Below the x-axis, the values y are negative values. But since the mod function only returns positive values, the section of the graph below this has to be what reflected above. Now, whenever you reflect a point in the x-axis, whenever you reflect a point in the x-axis, the x-coordinate remains the same, but the sign of the y-coordinates change. So the point down here, which is minus 3, will become the point minus 3, positive 3. So this point here reflected, it's going to go up here, which is minus 3, 3. Or we can look at it like this. Whenever in a reflection, the object and the image are the same distance from the mirror line on either sides of the mirror line. So here you can see that the object is what? 1, 2, 3, 1, 2, 3 units below the mirror line. So the image would be the same distance but above the mirror line, which is 1, 2, 3. All right, so the point minus 3 becomes the point minus 3, positive 3. And then just connect that back to the origin. So the dotted line along with the section of the graph, the section of y is equal to x that is above the x-axis would be the graph of the mod of x. Y is equal to the mod of x. All right. So it would probably look something like this, and like this. So this would be the graph of y is equal to the mod of x. We obtain this from the graph of y is equal to x by reflecting the section of the graph that is below the x-axis. Additionally, whenever you reflect a point in the x-axis, the x-coordinate remains the same, but the sign of the y-coordinate changes. All right, example 28. Example 28 says sketch the graph of y is equal to x squared plus 3x plus 2. All right, first of all, and then ends, we're to sketch the graph of y is equal to the mod of x squared plus 3x plus 2. To sketch a quadratic graph, well, the first thing is that we already know the y-intercept, that the y-intercept is 2, the number at the end, the constant term will be the y-intercept. So I know that the graph cuts the y-axis at 2. Let's determine the x-intercepts. To determine the x-intercept, I must solve the equation x squared plus 3x plus 2 is equal to 0. Let's write this properly. Having a little trouble with my pen. All right, so that is x squared plus 3x plus 2 is equal to 0. X squared plus 3x plus 2 is equal to 0. It's working now. All right, let's factorize. I'm factorizing by trial and error. You could use the ABC method if you want. X, so x times x gives me x squared. And the two numbers I put here, when I multiply them together, I must get the number at the end. Sorry. All right, you must get the constant term. All right, so I think one should go here. Both of them should be positive. All right, so I just did that by trial and error is equal to 0. Therefore, x plus 1 is equal to 0, or x plus 2 is equal to 0. Therefore, x is equal to minus 1, or x is equal to minus 2. So those are my x-intercepts. All right, with that information, I can do a fairly good sketch. All right, so again, the y-intercept is 2. The x-intercepts are minus 1 and minus 2. So I know that my graph is going to pass through all those 3 points. All right, with that in mind, I can try and um, do a rough sketch. Of this graph. So this will be the graph of y is equal to x squared plus 3x plus 2. All right. Now to obtain the graph of the mod of x squared plus 3x plus 2, all I need to do is to reflect the section of the graph that is below the x-axis. So these points, the intercepts will remain the same. All right. And now the section of the graph above the x-axis will also remain the same. All right. having sketching problems. Alright, and all I need to do is just simply reflect the section that is below the x-axis to above the x-axis. Alright, and this would be the graph of y is equal to the mod of x squared plus 3x plus 2. Alright, so in order to sketch the graph of the mod of a function, we have to first sketch the graph of the function and then reflect the section of the graph that is below the x-axis reflected to above the x-axis. And once we do that, we'll have the graph of the mod of the function.